Hey guys, this is question MM014 of the Sharpen Maths Methods study guide. How to find the graph of an inverse based on an original function. So what happens here is we're given an original function f of x equals 2 take e to the power of negative x, which is shown here. Now, the important parts of this are you need to remember that an inverse occurs when an original function's x and y values are swapped. So that's a set of knowledge that we have to use here. So because there's a horizontal asymptote at y equals 2 on the original, that means that there's going to be a vertical asymptote at x equals 2 on the inverse, which I've drawn in here. Similarly, because there's a y value of 1 at the intercept there, on the original, in the inverse function, there's going to be an x equals 1 intercept there. Now, that immediately rules out 3 of these options, because they don't have an asymptote at 2, and they also don't have an x-intercept at 1. So A, it could be because there's an intercept at 1 there and asymptote at 2. B, it could be because there's an intercept at 1 and an asymptote at 2. However, D, immediately no, because it needs to translate to a vertical asymptote when you do the inverse of it, and same with E. Now C does have a asymptote at x equals 2, however, it doesn't have an x-intercept at x equals 1, which is over here, so it can't be C. So we immediately know that it has to be A or B, and now we just need to figure out which one. So I like to think of the inverse as the original function being reflected over the y equals x axis. So if you're unsure, I like to draw the y equals x axis, which is just a diagonal line through the middle, and if you can imagine flipping it over that axis. So it sort of needs to look the same on both sides, if that makes sense. So if you were to draw it, it would sort of look like that and intersect at that point, because you're basically flipping it over that side. From here, you can actually see that B looks nothing like what I've just drawn, however A does, which means that A is our final answer.